All right, today we're tackling, well, the biggest question there is. Where did everything come from? I mean, seriously, this isn't just some science problem, it's the ultimate origin story. And let me tell you, it is a wild one. So let's dive right in. So really think about it. How did every star you see, every planet, every galaxy, heck, how did we come to be? It's the ultimate cosmic mystery, right? And our journey to figure this out, it starts at a single, unbelievably tiny point way back 13.8 billion years ago. And you know what? We actually have a pretty solid scientific answer. It's called the Big Bang Theory. And the idea is, honestly, it's kind of simple, but also totally mind-bending. It basically says that our whole universe, everything, burst out from this single point, what scientists call a singularity, that was incredibly hot, incredibly dense, and ever since that moment, it's just been expanding and cooling. Okay, to really get a grip on this, you gotta do one thing first. Forget the bang part. Seriously, this is not the explosion you're probably picturing in your head. A much better way to think about it is with a simple analogy. Let's just imagine for a second that the entire universe is nothing more than the surface of a balloon. And now, let's say we grab a marker and just draw a bunch of little dots all over that balloon. Now, each one of those dots, that's a whole galaxy, like our own Milky Way. Before we do anything, they're all kind of packed in there pretty close. But here's the magic trick. This is the crucial part. What happens when you start blowing up the balloon? Well, all the dots start moving away from each other, right? And here's the really important bit. They aren't sliding across the balloon's surface. No, the rubber itself, the fabric of space, is stretching, and it's carrying those galaxies along for the ride. And that little balloon trick? It totally shatters the biggest misconception people have about the Big Bang. See, it wasn't an explosion in space, like some cosmic firework. It was an expansion of space itself. And it was happening everywhere, all at once. There was no center, because the event was the creation of the center and the edge and everything in between. So, you might be thinking, okay, that's a nice story, but how could we possibly know what happened 13.8 billion years ago? Well, just like in any good detective story, the cosmos left clues. It left evidence behind. And for the last 100 years or so, astronomers have been playing detective. Let's look at what they found. So, our first huge piece of evidence takes us back to 1929. There was this astronomer, you've probably heard of him, Edwin Hubble. And he was looking through this super powerful telescope at galaxies way, way out there. And he saw something that completely changed how we see the universe. What he noticed was that almost every galaxy he could see was moving away from us. But there was more. He found this incredible pattern. The further away a galaxy was, the faster it was flying away. It was a perfect relationship, and we now call it Hubble's law. This was it. This was the first solid proof that our universe is expanding, just like that balloon. All right, let's jump forward to 1965 for our next clue. We've got two radio astronomers, Arno Penzias and Robert Wilson, and they're using this huge radio antenna. But they've got a problem. There's this constant, annoying static, this hiss in their signal they just can't get rid of. I mean, they tried everything. They even cleaned out pigeon droppings from the antenna, thinking maybe that was it. But nope, the hiss was still there. Well, it turns out that annoying hiss was actually one of the most important discoveries in the history of science. What they had found, completely by accident, was the cosmic microwave background. It's this faint glow of energy that fills the entire sky, coming from every direction. This wasn't just static. It was the leftover heat from the creation of the universe itself, the literal afterglow. It's the oldest light we can possibly see. And clue number 3? It's hidden in the universe's recipe book. The math behind the Big Bang actually predicts what the early universe should have been made of. It says that cosmic fire should have cooked up the lightest elements in a really specific ratio, about 3/4 hydrogen and 1/4 helium. So what happens when we look at the oldest, most pristine parts of the universe? You guessed it, that's exactly what we find. Another perfect piece of evidence. So you take all these clues together, and scientists have been able to work backwards to piece together a timeline of creation. It's kind of like looking at the universe's baby pictures. So let's do a quick flyby of the first few moments after the universe was born. And things happened fast. I mean, it's just mind-boggling. In the very first second, the basic building blocks of matter,
protons and neutrons, popped into existence. Just 3 minutes later, things had cooled down enough for those to stick together and form the first atomic nuclei, mostly hydrogen and helium. But for the next 380,000 years, the universe was just this hot, soupy fog. Then it cooled just enough for atoms to form, and bam, the universe suddenly became clear, letting light travel freely for the first time. That's the light we see today as the cosmic microwave background. And it would still take another 100 million years or so before gravity could finally start pulling all that gas together to light up the very first stars.
But just like in any good mystery, when you solve one clue, you often just uncover an even bigger puzzle. The Big Bang Theory is an incredible success story for sure, but maybe its greatest achievement is showing us just how much we don't know. It points to some seriously huge cosmic unknowns. See, the theory is fantastic at explaining what happened from the first tiny fraction of a second and everything after, but it tells us absolutely nothing about the moment of creation itself, or what came before it, if before even makes sense. What caused the Big Bang? Right there, at that moment, all of our physics just breaks. It leaves us with maybe the biggest question we can even ask. And then there's this thing called dark matter. It's a huge mystery. When we look at galaxies, we see they're spinning way too fast. Based on all the stars and gas we can see, they should have flown apart ages ago. Something else, some invisible glue, has to be holding them together with its gravity. And this stuff outweighs everything we can see by about 5 to 1. We know it's there, but we have no clue what it actually is. And if you thought that was weird, hold on. There's also dark energy. For the longest time, everyone figured that gravity would be putting the brakes on the universe's expansion, right? Makes sense. But in the late 90s, scientists discovered the exact opposite was happening. The expansion is actually speeding up. Some strange, mysterious force is pushing everything apart. And this dark energy, it makes up something like 70% of the entire universe. So where does that leave us? Well, with this final, absolutely mind-bending idea. The Big Bang gives us this incredible story of where we came from. A whole universe, born from a point smaller than an atom. It's an amazing journey into our past, but it also shows us that for everything we figured out, there's so much more still hiding out there in the dark, just waiting for us to find it.